Okay, now we're going to test the difference between two means with a special case where population standard deviations are known. This is usually not the case. It's usually we don't have the population standard deviation, but there are cases where we assume we know the population standard deviation. So we're going to show you how to test a claim for the difference between two means. Carla is comparing automobile insurance premiums in Arizona with those in California. So we have two sets, two samples. A random sample of 32 insurance companies in Arizona yielded a sample mean of 735 with a known population standard deviation. Once you guys see known population standard deviation, that's a sigma, not an S. And if he gives me sigma, we cannot use the T test. We must use the Z test. Be aware of this. So you can see here, I put X1 bar under Arizona 735. I didn't put S1, I put sigma 1, 185, and 1 is 32. An independent random sample of 36 insurance companies in California gave a sample mean of 820. So X2 bar is 820. Known population standard deviation, so that's sigma 2, which is 225 here. Sorry, I put 185 by mistake. And sample size is what, 36. Test to see if the data supports the hypothesis that insurance premiums are lower than in Arizona than they are in California. So if we let mu1 be the population mean cost of insurance in Arizona and mu2 the one in California, we need to test that mu1 is less than mu2, and this is the claim. So we're gonna run what we call Z-stats using StatCrunch. To sample with summary. I don't have the actual data, so we select with summary. Again, you always, most of the time, you use T-stats, but when he gives you population standard deviation, you must use the standard normal curve, the Z distribution. Okay? And let me walk you through the steps. So stat, Z-stats, to sample with summary, and let's reduce this a little bit so you can see the entire screen. Sample 1, mean is 735. Population standard deviation now 185. Sample size is 32. The conditions of the test, guys, are met because the samples are random, they are independent, population standard deviations are known, so we can use Z-test. And the sample size is more than 30, even if he doesn't say that the populations are normally distributed. As long as the sample size is 30 or more, the conditions of the test are met. Sample 2, the mean is 820, and the population standard deviation, they say 225, and the size of the sample was 36. Let me show you what else we need to do. Okay, you don't touch the 0. Okay, the only thing is you check the alternative sign. We need to test that mu1 is less than mu2. It's the same thing as testing mu1 minus mu2 is less than 0. It's exactly the same thing. And if you guys want to show the p-value, you can do a p-value plot. Let's hit compute. And the test statistic is negative 1.708 for two decimal places will be negative 1.71. And the p-value is 0.0438. Since the p-value is less than alpha, we're going to reject the null hypothesis and support the claim because the claim is in the alternative hypothesis. The p-value is going to be a shaded region under the curve to the left of the test statistic, negative 1.71. Let me show it to you. Look, this is negative 1.71 right here. And look at the p-value is right here. Why it is area to the left? Because the test is a left tail test. When you have a less than, the p-value will be on the left. If you have a greater than, the p-value will be on the right. And if you have not equal to, the p-value will be on both sides of the curve. So let's go back to the question and finish the remaining steps of the test. So Z is negative 1.71, p-value is 0.0438, which is less than alpha. If p-value less than alpha, you need to memorize that. You reject the null hypothesis. And if we reject the null hypothesis, we reject HO, and the claim is in H1, then you support the claim. You say there is enough evidence at the 5% level of significance to support the claim that insurance premiums are lower in Arizona than they are in California. For students who are taking the course on campus and your book, for less than in the alternative, it uses the greater than or equal to. In the null, you can put greater than or equal to. It doesn't matter. And some other books just use the equality, the equal sign in the null hypothesis also. That is fine. As long as your alternative sign is correct, it doesn't matter whether you put equal here or you put greater than or equal, which is the complement of less than.